Hey everyone, welcome back to my channel. My name is Andrew, and in this video we're talking about dimensional analysis, continuing with the length dimension as a scalar, and then defining displacement as a vector. So I know you guys are really busy with your classes, so this is actually the last slide. So if you think that you're comfortable with everything on this slide, then you should skip this video. Otherwise, we're going to be defining everything on the screen and defining vectors. So as you can tell, we're talking about dimensional analysis. Last time we talked about mass, which is one of the fundamental base dimensions, has units of kilograms. And in this video, we're talking about length, one of the other fundamental base dimensions, has units of meters, and its dimension is in length. So it's a capital L. And it can be defined as both a scalar and a vector. And we're going to talk about what that means. Length is just length, like how long something is. It's a scalar. It has a magnitude, has no direction. So like, how tall are you? Oh, I'm 5 foot, whatever, 5'9". What's the distance from Los Angeles to New York or United States to India? Those distances can be defined using length scalars. They're just numbers, a physical number, this many miles, etc., etc. So let's talk about length as a scalar because we live in 3 dimensions. So that means we can define length as in, let's say, the x direction, and then width, let's say, in the y direction, and z, which is going to be depth. So if you combine length, width, and depth, you're going to have a 3-dimensional object like a cube, just like classic geometry. But reminder that these are still scalars. These are still scalar quantities, so we can define volume, area. These are still going to be scalars. So length is the scalar quantity that describes the distance between 2 points in space in an arbitrary coordinate system. So what do I mean by arbitrary coordinate system? That means that length, width, and depth, you can define the length to be the depth coming in and out of the page if you want to. You can define the width to be at an angle. But whatever you define it to be, you have to be consistent with those coordinates. Okay, so just think about geometry, just think about algebra. Whenever you're defining your coordinate system, you have to be consistent. So now we can define what is a vector. So the first way we're going to do that is by defining the displacement vector. So if we define length as a scalar, that's just the distance between 2 points in space. Let's just say that's, I don't know, 1 meter. We can define length as a vector, a displacement vector. A vector is just an arrow. So the displacement vector is just the arrow pointing from a point A to a point B in space. And it has that direction in the x direction. And it has the value of the length from A to B, okay? So length is a scalar, displacement is a vector. The displacement vector is an arrow pointing from one point to another point in space on an arbitrary coordinate. Again, we have arbitrary coordinate systems. It could be X, it could be Y, it could be Z, it could be R, it could be anything you want to define it to be. And notice how I write length as a scalar with just the X, and then displacement as a vector with an x with a little arrow on top. So that means that the x displacement vector is indeed a vector, whereas length is a scalar, it has no arrow on top. So for length, we're going to have the x direction, and we're going to have the x vector, the arrow pointing from A to B, and then see that little x with the little hat on top? We'll talk about that in a second, but that's just a little arrow pointing in the same direction. And then similarly for width, we're going to have y arrow pointing from A to B in the y direction. And again, the little y with the little hat on top, that's another vector. We'll talk about that. And then finally for depth, that's going into and out of the board. So depth is going to be that z arrow pointing from A to B. And one more time, that little z with that little hat arrow on top. So the displacement vector connects 2 points in space along the unit vector, which now we're going to talk about what is a unit vector. So if we point from A to B, we have that first little vector. So that little vector with that little arrow, that little hat on top, that's called a unit vector. All right. So a unit vector is a vector. It's a vector. It's an arrow with the value of 1. So unit, think like unit circle. What's the radius of a unit circle? 1. What's the size of a unit vector? 1. It has the value of 1 pointing in the direction of an arbitrary axis. So again, it's a vector. So if we define it in the x direction, the x hat, so from now on, I'm going to call that x hat, is going to be equal to the vector, x, the vector, divided by the magnitude of the vector. So those bars mean magnitude. How do you calculate magnitude? We'll talk about that in a second. So magnitude is a scalar. Magnitude is the length of the vector, and then the x arrow is itself. So if you divide anything by itself, you're just going to get 1. So that's why it's the value of 1. And so it's just in that pointing that direction. So that's the x hat vector. Do the same thing for the y hat vector. So it's the y vector pointing from a to b in the y direction divided by the length of that. So it has the value of 1 pointing in the y hat direction. And the z hat is going to be the vector z pointing from a to b in the z coordinate system, and it's going to be equal to the z vector divided by the magnitude of the z. So all these unit vectors have a value of 1, and they're pointing along that x, y, and z coordinate system. So if you've never been exposed to vectors or vector calculus before, they might be looking a little funky, a little bit abstract, a little weird, but it turns out that they make things really intuitive, and they can be very useful for defining functions in classical mechanics in physics. So now that we have the vector itself in the x hat direction of the unit vector, we can define the vector itself. So in vector, again, a vector is an arrow pointing 2 points in space in the direction of a unit vector. So we're connecting A to B along the x hat direction. So that's the x hat displacement vector. So the length is going to be x. The length is what? The length is a scalar. That's just the value of x. The unit vector is x hat. So the displacement vector is going to be the x vector, and it's going to be equal to the magnitude in that direction. So that is why scalars are just magnitude and vectors are magnitude with the direction. So in length, in the x direction, we have the x displacement vector. And so what's the magnitude? X. What direction is it? X hat. In the y direction, we have width. What's the magnitude? Y. What direction is it in? Y hat. In the z direction, we have depth. What's the magnitude? Z. What direction is it in? Z hat. So how do we apply this? So how do we get from point A to point B? Well, one way is we go 4 units in the x direction and 3 units in the y direction, okay? But you and I both know that a more direct way is just going from A directly to B along this r direction, okay? So what can we do with that math? We can define the length of the r, the length. So this is a scalar still, okay? So if x equals 4 and y equals 3, what is going to be the length of r? Well, we know the Pythagorean theorem, and we can solve for that length is going to be 5. So if we define length as a vector, this r as a vector, so now we're going to put an arrow from point A to point B, and then define the vector r to be 4, 3. So now I'm going to put the brackets. So every time I put brackets, that means that I'm using a vector notation. It is not a point anymore. It is not a point in space. It is the vector 4, 3. So r is a vector with the value of 4 in the x direction and 3 in the y direction, okay? That's a vector, 4, 3. That's the vector, but it has to be in brackets. It has a value of 5 in the direction pointing to the point 4, 3 in the direction of r. So now we have a new vector, which is going to be in the r direction. So in general, the vector r is going to be given by the vector x, y, again with brackets. So the r is a vector with the value of x in the x direction and y in the y direction. And it can be written by adding those two together. X in the x direction plus y in the y direction. But notice that x hat doesn't interact with y hat, and that x and y represent points in space. They're not just the variables. So you're not going to be adding 4 plus 3 is 7, because we know that the hypotenuse is not 7. It's going to be 5. So we're using the Pythagorean theorem to define a new vector in space. So if r is going to be x in the x hat direction and y in the y hat direction, we have two displacement vectors, which are going to be x in x hat and y in y hat. So the unit vectors are just the tiny little arrows with the value of 1, because unit means 1, and so they're pointing along the x and y coordinates respectively. So we can define the displacement vectors as functions of the unit vectors. So this is why dimensional analysis is so important. We define mass as a scalar, we define length as a scalar and a vector. I'm not going to define time because that can get really funky with Einstein's general relativity and special relativity. I probably won't be doing that on this channel. But if we have mass, length, and time, we can define everything else. Time, temperature, electric current, luminous intensity, and amount. Remember, those are the fundamental base dimensions, and everything else you can define in terms of the other dimensions. Okay, so that could be force, mass times acceleration, momentum, mass times velocity, energy, force times distance. Those are all functions of mass, length, and time. And we are also going to have to use temperature when we talk about heat transfer. So whether you're in high school learning physics and chemistry, whether you're in college taking your fundamentals of mass balance, you're in your fluid mechanics courses, you're in your thermal courses, all of these incorporate dimensional analysis, and there's no way to get around that. In fact, dimensional analysis makes things easier and intuitive. So we're going to be studying this table for a very long time. That being said, thanks a lot for your attention. Please let me know if you have any questions, and please leave a comment, give me some feedback. It really helps me out. Seeing what you guys are struggling with, what you're stuck on, makes me remember what I was struggling with, what I'm currently struggling with, what I got to work on. Don't forget to share this with your friends, family, and dog.